Okay, good morning. Welcome to
Math number 281.
281. Yeah. So today we're going to do another short project inspired by this Richard Green post, and it's about an amazing unsolved problem. But although this problem is unsolved, I think you guys can actually start to understand why it's interesting and even learn a little bit from it. So Richard Green writes the number. Do you know what number that is?
Isn't it 82,000?
82,000 and base 10 is equal to that number in base 2.
Wow.
You want to read that out? How about we don't read that one
Yeah.
out? It's equal to this number in base 3, this number in base 4, and that number in base 5. What's common about
Well, they're
those
all
numbers?
made of ones and zeros.
Yeah.
Isn't that interesting?
Yeah.
So it's the first number that is made up entirely of ones and zeros in base 2, base 3, base 4, and base 5.
What about in base 6? Does the pattern break?
That's a very good question, actually, and that's
Well,
what this post is
Isn't
about.
there a nut? Wouldn't one work? It would be one in base 2, one in base 3, one in base 4, and one in base 5.
Oh, very good. You caught me actually being imprecise. You're absolutely right. 1 is the first number,
Then this one.
and then that one. Yeah, I guess 0 may even be the first one.
If you were just looking at positive numbers.
Yeah. Now, is it surprising that this number, 82,000, is just ones and zeros in base 2?
No, because you have to be ones and zeros in base 2.
Okay. What do you think about an integer in base 3 and base 4? Is it more likely that an integer is going to be ones and zeros in base 3, or more likely that it's going to be ones and zeros in base 4?
More likely that
in
it would
base
be in
3.
base 3.
How come?
Because you're using less digits in base 3.
Yeah.
Okay.
You can only use zeros, ones, and twos.
Pretty interesting. So he continues down here. What's remarkable about this property is how much the situation changes if we ask the question, if we alter the question slightly. The smallest number bigger than 1 whose base 2, 3, and 4 representation consists of zeros and ones is 4. If we ask the same question for bases up to 3, the answer is 3, and for bases up to 2, the answer is 2. The question does not make sense for base 1. Why not?
Because that's just zeros.
Yeah.
Base
Which is
1
what leads to
doesn't
the sequence
exist.
2, 3, 4, 82,000. So 2 in base 2, 3 in base 2 and 3, 4 in base. What is 4 in base 3?
4 in base 3, well, I think that would be 1, 0. It's 1. Wouldn't it be 1, 1?
1, 1, very good. And then 82,000. So you asked about what if we extend to base 6? And that's what he talks about down here. That's the unsolved problem. No one knows. No one knows.
Maybe
In fact,
there isn't one.
maybe there isn't one.
How large have they checked?
Well, good question, actually. You guys are asking some good questions, and he's even answered some of them. They've checked up to numbers that are 3,125 digits in base 5.
Wow.
So super long numbers.
Yeah.
But I thought it might be fun to explore this a little bit.
Okay.
And even one more thing that's amazing, by the way, is no one even knows if there's another number above 82,000 that's just all ones and zeros in base 2, 3, 4, and 5. Even that's unsolved.
Wow.
Yeah, wow. So let's take a look at this question and see if we can do a little exploring, okay?
Okay.
All right.